Chapter 2, Class 6, Whole Numbers. Before learning what we are going to do in this session, we just quickly recap all those concepts which we have already learned in the previous sessions. So the first one is, what are whole numbers? And we learned that whole number is a collection of natural number and zero, and natural numbers are those numbers which starts from 1. Then we have learned about two properties of whole number. The first one is closure property, and we find out that whole numbers are closed under addition and multiplication, but they are not closed under division and subtraction. The second property of whole number is commutative property, and we find out that addition and multiplication, they are commutative for whole numbers, but subtraction and division are not commutative for whole numbers. Now in this session we are going to learn one more property of whole number, and that property is known as associative property. So let's see what does associative property states. We are going to learn about associativity of addition and multiplication. Why? Because associativity of subtraction and division does not exist. You can also verify it by taking some examples. So in this session I am going to discuss about associativity of addition and multiplication. Associative property. It states that we can add or multiply the numbers regardless of how the numbers are grouped. That is, we can group them for convenience of addition and multiplication. So associative property says that we can add or multiply the numbers without thinking about how the numbers are grouped. We can regroup them as per our convenience for finding the sum and product of given numbers. But the question which arises is, why do we need regrouping of numbers? We can easily find the product and sum of numbers by just adding and multiplying them. So why we need regrouping? So to understand this, just look at the following examples. Here we have to add three numbers, 837, 208 and 363. So normally we proceed like this. First of all, we just add 837 and 208, and after finding the sum of these two numbers, we just add 363 to it. So the procedure is, first add 837 and 208. So answer is 1045. Now add 363 to it. So 1045 plus 363 equals to 1408. So this is the normal procedure which we usually follow for finding the sum of given numbers. Now let's try to find the sum using another way. We are going to add 837 and 363. Instead of adding 837 and 208, I am going to add 837 and 363 before. So the sum is 1200. After finding the sum, I am going to add 208 to this sum. So 1200 plus 208 equals to 1408. So here, first of all, we add 837 and 208. The answer is 1045, and then we add 363 to it and we get 1408. Here we add 837 and 363 before, and the answer is 1200. Now we are going to add the third number 208, and after adding we are going to get 1408. So in both the cases the answer is same. The only difference is, in the first one we are grouping 837 and 208 together, and in the second one we are grouping 837 and 363 together. So why we are regrouping them? Just to make our calculation easier. The second calculation which we have done is much easier than the first one. So after regrouping, our calculation become easier. So this process of grouping the numbers together has made the calculation easier. That is why we are regrouping the number for finding the sum and product of given numbers. Now let's try to find the product of given numbers using regrouping. So again, we are going to find the product of 8, 1769 and 125. So the normal way of finding the product is, first multiply 8 and 1769. After multiplying, we are getting 14,152. Now multiply this product by 125. So after multiplication, we are going to get 17,69,000. So this is the product of these three numbers. Now let's try to find out this product by regrouping the numbers together. So after regrouping, we are going to multiply 8 and 125 before. So after multiplying 8 by 125, we are going to get 1000. And now I am going to multiply 1000 by 1769. So we can quickly calculate this product, and the answer is 17,69,000. So by following this procedure, we can easily find out the product of these three numbers. So the process of grouping the numbers together has made our calculation easier. That is why we always try to group the numbers together for finding the sum and product. Now let's move on to associative property of addition and try to find out whether whole numbers are associative with respect to addition or not. So again, we are going to analyze this by using some examples. So the first example is, I am going to add 2, 3 and 4 in two ways. In the first one, I am going to add 2 and 3 before. So 2 plus 3 equals to 5, and then add 4 to it. So 5 plus 4 equals to 9. In the second way, I am going to add 3 and 4 before. So 3 plus 4 equals to 7, and now add 2 to it. So the answer is 9. So in both the ways, the answer which we are getting is same. That means 2 plus 3 plus 4 is equals to 2 plus 3 plus 4. Similarly, in the second one, I am going to add 5 and 7 before, and then I am going to add 3. So 5 plus 7 equals to 12 and 12 plus 3 equals to 15. Here I am adding 7 and 3 before. So 7 plus 3 equals to 10, and now add 5. So 5 plus 10 equals to 15. Again the sum is same. So that means 5 plus 7 plus 3 is equals to 5 plus 7 plus 3. Similarly, in the last example, we are getting that 2 plus 8 plus 6 equals to 2 plus 8 plus 6. So from these three examples, we are getting that addition is associative for whole numbers. Why? Because we can regroup or we can associate any two numbers together for making our calculation easier. So this property is known as associative property, and by examples we see that addition is associative for whole numbers. Now let's see whether multiplication is associative for whole numbers or not. So now we are going to learn the associative property for multiplication. But before learning it, we have to justify whether multiplication is associative for whole numbers or not. So again, let's take some examples. Here I am multiplying 2, 3 and 4 in two ways. In the first one, I am multiplying 2 and 3 before. So 2 multiplied by 3 equals to 6. And now multiply 4. So 6 multiplied by 4 equals to 24. In the second one, I am multiplying 3 and 4 before. So 3 4s are 12. And now multiply 2 with 12. So 2 multiplied by 12 equals to 24. So from these two examples, we are getting that 2 multiplied by 3 multiplied by 4 equals to 2 multiplied by 3 multiplied by 4. That means the answer which you are getting by doing multiplication in both the ways is equal. Now similarly, multiply 5, 7 and 3. So in the first one, I am multiplying 5 and 7 before. So 5 7s are 35, and now multiplied 3 with 35. So 35 3s are 105. In the second way, multiply 7 and 3 before. So 7 multiplied by 3 equals to 21, and now multiplied 5 by 21. So 5 multiplied by 21 equals to 105. Again we are getting that 5 multiplied by 7 multiplied by 3 equals to 5 multiplied by 3. Similarly, in the last example, I am multiplying 2, 8 and 6 in two ways. And after multiplication, we are getting that the answer which we obtained by multiplying 2, 8 and 6 in two ways is equal. So which means 2 multiplied by 8 multiplied by 6 equals to 2 multiplied by 8 multiplied by 6. From these examples, we are getting that multiplication is associative for whole numbers. Why? Because we can associate any two numbers for making our multiplication more convenient and easier. So that is why whole numbers are associative with respect to multiplication. So we get that whole numbers are associative with respect to addition and multiplication. Now we are going to check whether whole numbers are associative with respect to subtraction or not, and whole numbers are associative with respect to division or not. So again I am doing this by taking some example. Here I am taking 3 whole numbers. The first one is 7, second one is 6, and the third one is 5. Now subtract 6 from 7 before. So 7 minus 6 comes out to be 1. Now subtract 5 from 1. So 1 minus 5 comes out to be minus 4. Now do this calculation in another way. In another way means you have to subtract 5 from 6 before. So 6 minus 5 equals to 1, and now subtract 1 from 7. So 7 minus 1 equals to 6. So we have done this calculation in 2 ways, and in both the ways we are getting different answers. In the first one we are getting minus 4, and in the second one we are getting 6. That means 7 minus 6 minus 5 is not equals to 7 minus 6 minus 5, which means we cannot associate whole numbers for subtraction, which implies that subtraction is not associative for whole numbers. Now let's check whether division is associative for whole numbers or not. Again I am taking 3 whole numbers. The first one is 24, second one is 6, and the third one is 2. I am trying to find out the solution in 2 ways. In the first one I am dividing 24 by 6 before. So after division we are getting 24 divided by 6 equals to 4. Now divide 4 by 2. So 4 divided by 2 equals to 2. Now we are doing this calculation in another way. In another way means we are dividing 6 by 2 before. So 6 divided by 2 equals to 3. Now divide 24 by 3. So 24 divided by 3 equals to 8. So here we are getting 2 different answers irrespective of the fact that the whole numbers are same. Since we are getting 2 different answers, which means 24 divided by 6 divided by 2 is not equals to 24 divided by 6 divided by 2. So here we are getting an example of whole numbers in which we see that we cannot associate any 2 numbers together, which means division is not associative for whole numbers. So from all these examples we are getting that whole numbers are associative with respect to addition and multiplication, but whole numbers are not associative with respect to subtraction and division.